Your storage account key is similar to the root password for your storage account. It can be used to access the data objects stored in the storage account, such as blobs, tables, files, and queues. Giving out your storage account key is like sharing the keys of your storage kingdom. It grants complete access. Now, someone could use your keys and upload their entire music library to your storage account. They could also replace your files with virus-infected versions or steal your data. Giving away unlimited access to your storage account is something that you should not take very lightly. An alternative to giving away your storage keys is to delegate access to your storage account objects using shared access signatures. You can grant access to blobs, containers, queue messages, files, and tables. With tables, you can actually grant permission to access a range of entities in the table by specifying the partition and row key ranges to which you want the user to have access. With shared access signatures, you can grant a client just the permissions required for a limited amount of time. For example, if someone is uploading a blob to your account, you can grant them write access for just enough time to upload the blob. And if you change your mind, you can revoke that access. Additionally, you can specify that requests made using a shared access signature are restricted to a certain IP address or IP address range external to Azure. You can also require that requests are made using a specific protocol, such as HTTPS, or both HTTP and HTTPS could be allowed. This means if you only want to allow HTTPS traffic, you can set the required protocol to HTTPS only, and HTTP traffic will be blocked. A shared access signature is a set of query parameters appended to the URL pointing at the resource that provides information about the access allowed and the length of time for which the access is permitted. It provides delegated access to resources in your storage account. With a shared access signature, you can grant clients access to resources in your storage account while sharing your account keys. This is the key point of using shared access signatures in your applications. A signature or a shared access signature is a secure way to share your storage resources without compromising your account keys. A signature gives you granular control over the type of access you grant to clients who have the signature, including the interval over which the shared access signature is valid, including the start time and the expiry time. The permissions granted by the shared access signature. For example, a shared access signature for a blob might grant read and write permissions to that blob, but not delete permissions. You can also specify an optional IP address or range of IP addresses from which Azure Storage will accept the shared access signature. For example, you might specify a range of IP addresses belonging to your organization. You can also specify the protocol over which Azure Storage will accept the shared access signature. You can use this optional parameter to restrict access to clients using HTTPS. You can use a shared access signature when you want to provide access to resources in your storage account to any client not possessing your storage account access keys. Your storage account includes both a primary and secondary access key, both of which grant administrative access to your account and all resources within it. Exposing either of these keys opens your account to the possibility of malicious or negligent use. Shared access signatures provide a safe alternative that allows clients to read, write, and delete data in your storage account according to the permissions you've explicitly granted and without need for an account key. A common scenario where a shared access signature is useful is a service where users read and write their own data to your storage account. In a scenario where a storage account stores user data, there are typically two design patterns. In the first design scenario, clients upload and download data via a front-end proxy service, which performs authentication. This front-end proxy service has the advantage of allowing validation of business rules. For large amounts of data or high-volume transactions, creating a service that can scale to match demand may be expensive or difficult. The second design pattern uses a lightweight service that authenticates the client as needed and then generates a shared access signature. Once the client receives the shared access signature, they can access storage account resources directly with the permissions defined and for the interval allowed by the shared access signature. This mitigates the need for routing all data through the front-end proxy service. Additionally, you will need to use a shared access signature to authorize access to the source object in a copy operation in certain scenarios. When you copy a blob to another blob that resides in a different storage account, you must use a shared access signature to authorize access to the source blob. You can optionally use a signature to authorize access to the destination blob as well. When you copy a file to another file that resides in a different storage account, you must use a shared access signature to authorize access to the source file. You can optionally use a shared access signature to authorize access to the destination file as well. When you copy a blob to a file or a file to a blob, you must use a shared access signature to authorize access to the source object, even if the source and destination objects reside within the same storage account. You can create two types of shared access signatures. The service shared access signature delegates access to a resource in just one of the storage services, that is, the blob, queue, table, or file service. The account shared access signature delegates access to resources in one or more of the storage services. A client who is in possession of a shared access signature can use it to authorize a request against a storage account for which they do not possess the storage account keys. A shared access signature can be included in a connection string or used directly from the appropriate constructor or method, say a .NET method, for example. If you possess a shared access signature URL that grants you access to resources in a storage account, you can use the shared access signature in a connection string. Because the signature contains the information required to authenticate the request, a connection string with a shared access signature provides the protocol, the service endpoint, and the necessary credentials to access the resource. When you use shared access signatures in your applications, you need to be aware of two potential risks. If a shared access signature is leaked, it can be used by anyone who obtains it, which can potentially compromise your storage account. Secondly, if a shared access signature provided to a client application expires and the application is unable to retrieve a new shared access signature from your service, then the application's functionality may be hindered. Setting recommendations for using shared access signatures can help mitigate these risks. It's advisable to always use HTTPS to create or distribute a signature. If a signature is passed over HTTP and intercepted, an attacker performing a man-in-the-middle attack is able to read the signature and then use it just as the intended user could have, potentially compromising sensitive data or allowing for data corruption by the malicious user. You should always have clients automatically renew the shared access signature if necessary. Clients should renew the signature well before the expiration in order to allow time for retries if the service providing the shared access signature is unavailable. Be careful with the shared access signature start time. If you set the start time for a shared access signature to now, then due to differences in current time according to different machines, failures may be observed intermittently for the first few minutes. In general, set the start time to be at least 15 minutes in the past, or do not set it at all, which will make it valid immediately in all cases. Be specific with the resource to be accessed. A security best practice is to provide a user with the minimum required privileges. If a user only needs read access to a single entity, then grant them read access to that entity and not read, write, delete access to all entities. This also helps lessen the damage if a signature is compromised because the signature has less power in the hands of an attacker. Validate data written using shared access signatures. When a client application writes data to your storage account, keep in mind that there can be problems with that data. If your application requires that data be validated or authorized before it is ready to use, you should perform this validation after the data is written and before it is used by your application. This practice also protects against corrupt or malicious data being written to your account either by a user who properly acquired the signature or by a user exploiting a leaked signature. Shared access signatures are useful for providing limited permissions to your storage accounts to clients that should not have the account key. As such, they are a vital part of the security model for any application using Azure Storage. If you follow the best practices listed here, you can use shared access signatures to provide greater flexibility of access to resources in your storage account without compromising the security of your application.